Assalamualaikum and hello everyone. So we will continue for a system which is in equilibrium, but in a special case where we have a particle or maybe an object at one point. So let's say in this diagram, it is in this figure, it is at B and it is attached with three forces attached to B. So we have T1, T2 and also 12 G Newton. So there are two methods if we want to find whatever force attached, whether we want to find the magnitude or the direction of each of the force. So we can use the method 1, triangle of forces, and also the method 2, Lami's theorem. So in this video, I will only explain about Lami's theorem. Okay, this is the formula for Lami's theorem. When P, Q, and R or the set of three forces is in equilibrium, so the formula is P over sine alpha, Q over sine beta, and also R sine gamma. So it depends whether we want to find the magnitude or we want to find the angle, which is alpha, beta, and gamma, or maybe the magnitude P, Q, R. So if let's say the formula here P, so you just remember this, we have a P and also the opposite angle would be alpha. So if we want to find for Q, okay, so the opposite angle would be beta. So it depends what value that we want to find. Okay, so let's look at the example. Okay, let's look at our question number 4. For each of the following system which is in equilibrium, use Lami's theorem to find the magnitude of forces P and Q. Okay, so let's start with A. So we have P, Q, and R. P, Q, and also 10 Newton. So if let's say P, so we do not know what is this angle. So we know, but what we know is that once a complete angle would be 360. So 360, and this square here is 90 degrees, and also we have 120. So 360 minus 90 minus 120, so we get 150. So sine 150. Okay, because we have another we have one P here unknown, so we need another one which is not an we need a value. Okay, so we cannot use Q because it's also an unknown, so we can use 10 here. So the opposite would be sine 90. So P is 10 over sine 90 times with sine 150. So our answer is 5. So here the unit is Newton, so we can just follow Newton. Okay, and then for B, we need to find Q first. Okay, so for Q, we have Q over sine 120. So how are we going to find P, Q? Okay, I think maybe I can just rewrite this back. Okay, so to make everyone can do can recall back or do your own you can look back the complete exercise here. So and then we have Q. So if Q, we can consider this fraction. So we will get Q is 10 over sine 90 times with sine 120. So we get 10 divided with sine 90 times with sine 120. So yeah, our answer is 8.66 Newton. So this is P and Q. Okay, let's look at C. Okay, you can try B later. Okay, for C, the answer is, okay, let's say we find this first. 360 minus 135 minus 60. 360 minus 135 minus 60. So your answer is 165 degree. Okay, so we have P sine 165. We have Q. Opposite of Q is sine 135. Then we have 5 square root 3 with sine 60. So if you want to find P, we can use this and this. So P is 5, 3, sine 60, sine 165. So divide with sine 60 times sine 165. So we get 2.59 Newton. Okay, and then for Q, we can use this and this. So 5 square root 3 sine 60 times with sine 135. So 5 square root 3 divide with sine 60 times with sine 135. So you get 7.07 Newton. Okay, example number 6. The diagram shows a light inextensible string with a one end fixed at A and a mass of 5 kilograms suspended at the other end. The mass is in equilibrium, so this is the key point, equilibrium at an this is the keyword, at an angle theta to the downward vertical by horizontal P. Okay, and it is explained in the figure. Okay, find theta by trigonometry. Okay, so that is the first question. You need to find theta, which is in the trigonometry, and then use Lami's theorem to find the magnitude of vector of the force P and the tension T. Okay, so there are two questions here, so you need to find the theta first. Okay, this one is by using trigonometry, so it means that whether we want to use sine, cosine, or tangent. Okay, so in this case, it is the length here is 30 centimeter, and also this one is 40 centimeter. So we have the opposite and also the adjacent. So if let's say trigonometry, we have the SOHCAHTOA. So if let's say we have the opposite and also adjacent, so we can use tangent theta. So tangent theta is opposite over adjacent. So theta will get 36.87 degree. So if let's say this is 36 and then we have 90, so the complete for a triangle angle is 130. So let's say we say this one is as phi. Okay, so phi is equal to 180 minus 36.87 minus 90. So the answer is 180 minus 36.87 minus 90. So we get 53.13. Okay, let's look at the force here. So we have 1, 2, and also 3. So this one is 90. And then we need to find this angle. So this angle is, this is also 90. So in this angle, we get 90 plus 53.13. So we get here 143.13. So once we get these two angles, so we can find this angle, which is 360 minus 143.13 minus 90. So we get 360 minus 143.13 minus 90. So we get 126.87 degree. Okay, so now we have the complete angle for each one of the force. So we can find T and also P here. Okay, so we have P. The angle opposite would be sine 143. And then we have T, which is sine 90. And then we have 5G. 5G, we have sine 126.13 6.87. So if we want to find P is 5G over sine 126.87 times with sine 1. Okay, so P is equal, okay, before that, Q here is G here, you substitute with 9.81. G is the gravity. We will learn more about the gravity in chapter 4. Okay, so we have sine 126.87 times with sine 143.13. So we get 36.79. Okay, Newton. Okay, and then we want to find T. So T is equal to 5G sine 126.87 times with sine 90. So we get 5 times 9.81 divide with sine 126.87 times with sine 90. So we get 61.31 Newton. So this is the final answer for P and T.